Hello everyone, welcome again. In our today's video we are going to look at the modulus or the absolute value of a complex number. So we have here a question: prove the modulus of z1 times z2 is equal to the modulus of z1 times the modulus of z2. When I say the modulus, remember the absolute value or the modulus of a complex number a plus bi, or I can write it here, the modulus or absolute value of a complex number a plus bi is defined as z, the modulus of z, which is equal to x plus iy, the modulus of this, which is equal to x squared plus y squared under root. This is what I mean. For example, if we are given a complex number, like for example z is equals to -4 plus 2i, then we are asked to find the modulus of this. So the modulus, what we'll do, the modulus of z is equals to, we square this -4, then we add 2 squared, then we find the square root out there. So it's -4 squared plus 2 squared under root out there, so that we get 16 plus 4 under root the square root of 20, we get 2 root 5. So that's all about the modulus out there. So in our question here, we have been asked to prove that z1, the modulus of z1 times z2 is equal to the modulus of z1 times the modulus of z2. Solution: the first step, we let z1 to be x1 plus iy1, and z2 to be x2 plus iy2. So the modulus, this left hand side of our question, z1 z2 will be the modulus of x1 plus iy1 times x2, and this is what I mean, that z1 times z2 are in there. So z1 is x1 plus iy1, then z2 is equals to x2 plus iy2, so x2 plus iy2. Okay, so we simplify what's in brackets. This is the same as x1 times x2 is x1 x2 out there, then x1 times positive iy2 is x1 iy2, then plus iy1 times x2, and we get x2 iy1 or iy1 x2, then positive iy1 times positive iy2, I times I is -1. Remember the square root of -1, the square root of -1, remember the square root of -1 is equals to I. So if we square I, we square I, we square the both sides of this, get I squared is equals to -1. So I times I is I squared, which is equal to -1. I times I equal to -1. Then y1 times y2 is equals to y1 y2. So it will be negative y1 y2. Are we there? Okay, so at this point we collect the like terms, the real parts, we put them together, and the imaginary parts together. Remember, the real parts are those that don't have I, as x1 x2 and negative y1 y2 are real parts, and those with i's are the imaginary parts. So it will be x1 x2 minus y1 y2 plus x1 y2 x2 y1, but we have an I there, the modulus of the whole of this. So the next step is to square this and this, then you find the square root. So it will be x1 x2 minus y1 y2 plus x1 y2 plus y1 x2 square then the square root of all of this, so that we get x1 x2 squared minus 2x1 x2 y1 y2 plus y1 y2 squared plus x1 y2 x1 y2 squared plus 2x1 x2 y1 y2 plus y1 x2 squared, the whole of this square root, the whole of this square root. Out there, this is the same as this. Raised power half is the same as the square root out there, so that we have x1 x2 squared minus 2x1 x2 y1 y2 plus y1 squared y2 squared plus x1 squared y2 squared plus 2x1 y2, continue because of the space, we just continue, 2x1 y2 y1 x2 plus y1 squared x2 squared, the whole of this under square root. Are we together? Then this becomes x1 squared x2 squared plus x1 squared y2 squared plus y1 squared y2 squared plus x2 squared y1 squared. There are some steps that I have omitted. I can see it is very tedious, but if you work it out, you follow each step, each and every step, I do believe that you will get here. So there are some steps I have omitted, but if you follow those steps, all those, or simplifying all this, you reach at this point. So the next step is to factorize what is in under root, under square root. For example, here we have x1 squared. X1 squared is common, so we have x1 squared into x2 squared plus y2 squared, then plus here what is common, y1 squared, so we have y1 squared the brackets y2 squared plus x2 squared right there under root. You can see that here we have x2 squared plus y2 squared, which is the same as y2 squared plus x2 squared. So I do believe that you know the laws of factorizing. So we have x1 squared plus x1 squared plus y1 squared, then we pick one edge of this they are the same, so we pick one, so that we have x2 squared plus y2 squared, the whole of this under root. So at this point we can confidently separate the two, so that we have x1 squared plus y1 squared under a root times x2 squared plus y2 squared under a root, and therefore z1 the modulus of z1 times the modulus of z2 is equals to this, which proves that the modulus of the product of z1 times z2 and z2 is equal to the modulus of z1 times the modulus of z2. So we have proved. Thank you so much for watching. Please do subscribe for more videos to come. Again, I repeat, you can suggest a video on a topic that you think somehow challenging, or you are not comfortable with it, so that I can create a video concerning that topic or about that topic. Thank you so much.